Hello, Algebra. Today we are going to be moving on to 4.2, where we're solving systems by substitution. In 4.1, we learned how to solve by graphing. We graph two functions, and this point where they intersect, that is the solution to the system. However, this isn't always feasible. Sometimes solving by graphing does not work. It's hard to solve by graphing, and we probably don't even have a graph. And so we use substitution. There are going to be, I should tell you, three ways to solve a system. We can solve by graphing, we can solve by substitution, or we can solve by elimination. Doesn't matter which one, but it depends on the situation, which one is better to use. So if it's an easy graph like 4.1, yes, we go ahead and we graph it and we solve. But sometimes it's not that easy and we have to solve by substitution. Substitution tends to be a good method as well. So if you have something like y equals 3, and they want us to solve for y and x, and y is equal to 3x plus 6, this might be easier to go with by substitution. And we don't have a graph to graph. If we're going to solve by substitution, we must be sure to isolate a variable. In this case, y is 3. And then we're just going to substitute the expression into the other equation and solve for both an x and a y. So if I look here, y is equal to 3 and y is equal to 3x plus 6. Well, if y is equal to 3, back in the days, wouldn't we just take 3 and substitute it in for y? That sounds right. So that 3 would be equal to 3x plus 6. And then we would go ahead and solve for x, because now the only variable left here is x. So I can minus 6 on both sides. So that negative 3 is equal to 3x. This, by the way, is going to take us back to chapter 1. It's a nice review of actually solving equations. So this is back to chapter 1. So now we know that x is equal to negative 1. We only have a part of it because every system is an actual coordinate point with an x and a y. So now we know that x is negative 1. And the y, well, we knew that from the beginning, y is equal to 3. So your solution to the system is negative 1, 3. And if you want to be sure, check. You should be able to tell your answers before I do. Y is 3. And then in the second one, we would put in 3 is equal to 3 times negative 1 plus 6. I'm using the y equals 3x plus 6 here. And so 3 is equal to negative 3 plus 6. So 3 is equal to 3. Yes, I know my solution is correct. Well, what if, as in number 3, what if it's an expression? So in this case, y is equal to 3x and y is equal to 2x plus 5. Well, wasn't it the same thing? Y was equal to 3 and we substituted it. But now y is equal to 3x. That's okay. I am just going to take 3x and substitute it in for y. So that 3x is equal to 2x plus 5. Y here was a number. We substituted it in. Y here is an expression, and we still just have to substitute it in. And once I do that, it's still going to be a matter of solving for x. So I would, in this case, get those x's together by subtracting 2x on both sides. So that x is equal to 5. Now I know x. X is 5. But my answer needs to be an actual solution with an x and y. To find y, I can use either the first or the second equation. And you get to pick. Doesn't matter. You get some options here. I'm going to go ahead and use the first one because it's shorter. That's the only reason. So now I know that y is equal to 3x. Well, I just found x. X is 5. I'm going to substitute the x that I found in for y. I'm sorry, in for x. So that y is equal to 3 times 5. Y is equal to 15. So now I have my x and now I have my y. My solution to the system is 415. This is your answer. That is your solution. That is the coordinate. This is your coordinate where two lines would intersect. Now, if you want to check your answer, then you can go ahead. I kind of know that the first one is true. Let me check in green. And you might say, Miss Reed, well, I'm good. I don't have to check. Checking is going to be your friend in this case, and you will be able to definitely know what you have for your answer. So y is equal to 3x. This solution should work. So 15 is equal to 3. Look at that. So I somehow put a 4 here. Don't know why. I do like that this is happening. Because when I came back, 3 times 4 is not going to give me 15. I realized, oh, Miss Reed, I wrote something wrong. I look back and I see that I actually had a 5 for my x. So checking does make a difference. I'm going to come now and I'm going to fix that. And I am going to put my true answer, which was 5. So my answer is 515. But checking, and I do want us to see that, it is in checking the answer that I was able to realize, I made a mistake. Let's try the second one. Y is equal to 2x plus 5. That means 15 is equal to 2 times 5 plus 5. And yes, that's true. I know I got my answer. I am good to go. That's number 3. I'm going to do one more with us. Let's see, what do I want to do? Let's do this one here. So y is equal to 3x minus 8, and negative 2x minus y is equal to 6. Well, if y again is equal to negative 3x minus 8, I'm going to take all of what it is and substitute it in for y. Y is that entire expression. So that my next step, I would have negative 2x minus y, which is negative 3x minus 8. And that is equal to 6. Go ahead and pause and kind of see what happened if you need to. But once I have set up my equation, now I'm going to go ahead and now I'm going to solve like I would any other day when I'm solving an equation. So I see a parentheses, I simplify the left, I simplify the right, and I move across the equal sign. So I have negative 2x, distribute the negative 1. I get positive 3x, and negative 1 times negative 8 is going to give me a positive 8, and it's equal to 6. Then I'm going to combine like terms. I see 2x and 3x, those are alike. So then I get x plus 8, and that's equal to 6. I'm going to minus 8 on both sides so that I could get x, and my x is equal to 2. Now that I have found x, I'm going to go ahead and solve for y. I'm going to solve for y. Get a space right here. I'm going to solve for y over here. So if I know that this is x, I'm going to pick one of these to solve for y. Personally, y is already by itself here in the first equation. So I'm going to go ahead and solve for it there. Let me call this yellow. Here's the yellow equation. And here's the blue equation. So because the yellow equation, the first equation is shorter and y is already by itself, I choose to use the yellow one. So that, let's get a different color. Y is equal to negative 3x minus 8. X I just found out was 2. So y is equal to negative 3 times 2. Just found that out for x. Minus 8. So that y is equal to negative 6 minus 8. And my y is equal to 8, 9, 10, negative 14. So now I know that my x is 2 and my y is negative 14. My solution is 2, negative 14. This is always weird. Let me put my answer right up here. Answer. 2, negative 14. But of course, I kind of want to check my answer. Let's see, 2, negative 14. And so I'm going to go ahead and check it. And I will check it with the green. I'm going to substitute it in for the first equation and for the second equation. All right, so I went ahead and checked my work. In checking my work, I see that this is okay for the first line, but this answer is not okay for the second line. So I say, oh my goodness, did I make a mistake? Because this isn't true. Because of that, I could start over. I could check my work and see. And I see that right here would have been an issue. 6 minus 8 is indeed negative 2, not positive 2. So we would go back and let's go ahead and fix these things because you missed one thing and something else happened. And then we're going to come right in here and we're going to change that portion. So when I look, 6 minus 8 would have given us negative 2, which means your x is negative 2. And so your y is equal to negative 3 times negative 2, positive 6 minus 8. So your y is equal to negative 2. Now my solution, my answer would be negative 2, negative 2. But of course, I am also going to check it just to make sure. So let's go ahead and check it. And so now that we have checked it and it works out for both equation, I know my answer is correct. I know the actual solution then is negative 2, negative 2. I want to give you a moment to just try out 2, 4, and 5. I want you to pause, see all the other ones, and try out 2, 4, and 5. Let me get you started on 2 because y is equal to x plus 4 and x is equal to 3. This happens to be on the bottom, but that's going to be okay. All you're going to do is still take that x and substitute it in for the x on top. Okay, go ahead and pause and try. All right, so for number 2, we would have gotten 3, 7, and I checked it. You should have checked it. Number 4, we would have gotten 3, negative 1. I substituted the blue into the yellow, the y for the y because the y was isolated. Number 5, we should have gotten negative 2, 1, substituted from the yellow into the blue because y is by itself. I substituted x plus 3 for y. If you chose to substitute 2x plus 5 in for the y, it would have given you the same equation, and we would have still gotten negative 2, 1. Again, be sure to check your work. These are my checks in green to confirm if I am good or if I am not. All right, so the last concept is just that. But here you always had a variable that was isolated, whether it was the y or the x. But of course, it's not always like that. Sometimes you have to isolate the variable first before you could even solve. So if I see 4x minus 5x equals 9, or I see x minus 4y equals 11, well, I don't want to try to isolate this y because there's a 4 in front, which means I might end up with a fraction. I don't want to isolate this x because there's a negative 5 in front. That might cause some problems again. I don't want to work with fractions, it's too much. I could isolate this y in the second equation, but I won't because, again, that coefficient is going to make things hard for me. So when choosing what you want to isolate, look for the variable where the coefficient is 1. That's what I want to isolate. And so I'm going to go ahead. I have x minus 4y equals 11. So I am going to isolate the x by adding 4y to both sides. So that x is equal to 4y plus 11. It is this that I'm going to use instead. Let me give you some colors. I am going to use this blue to substitute the other blue equation because it's just more rearranged so that my x is by itself. So then I will create a new system, which is 4y minus 5x equals 9. And x is equal to 4y plus 11. So this is my new blue, my new equation that I'm going to use. And in essence, this is the problem I'm going to solve. So all I did from step 1 to step 2 is I rearranged it so that I had a variable that was isolated. So now I'm going to go ahead and now I'm going to substitute all my x in for x, such that we have 4y minus 5 times x, which is 4y plus 11, and then that's equal to 9. From here, I'm going to solve like I would any other day. So I'm going to go ahead and I'm going to solve in blue. 4y, I see I'm simplifying the left, the right, moving across the equal sign. My left side has a lot going on. So I'm going to go ahead and simplify it. 4y, I'm going to distribute that negative 5 so that I get negative 20y. Negative 5 times 11 is going to give me negative 55. And then that's equal to 9. I'm going to combine like terms. 4y minus 20y is going to give me negative 16y minus 55. That's equal to 9. Now I'm just down to a two-step equation. So I'm going to add 55 to both sides. Negative 16y is equal to 64. Then I'm going to divide both sides by negative 16 so that my y is equal to negative 4. Now that I know y is equal to negative 4, I'm going to go ahead and find x. Well, I already have x isolated. That's my blue formula, my blue second one here down at the bottom. And I know that x is, it's actually even here. X is equal to 4y plus 11. So whatever my y is, I'm now substituting that in. So x is equal to 4 times negative 4 plus 11. That negative 4 again is the y. So that my x is equal to negative 16 plus 11. My x then is equal to negative 5. So the answer to my system, my solution, is negative 5, negative 4. I'll go ahead and highlight that in yellow. And of course, I am also going to go ahead and check. All right, now that we have checked, we know our answer is good. We are good to go. Now let's check out number 2. Again, talk it out with me. Which one would you like to isolate? 1, 2, 3, or 4? I see my variables. I think we want to go ahead and isolate 2 because it's the only variable where the coefficient is 1. If there's more than one, then you can feel free to pick. But in this case, that's the only variable where the coefficient is 1. That's the one that you should isolate. So let's go ahead and do that. I have negative 2x plus y, that's equal to 8. What would we do? We are going to add 2x to both sides. And feel free to pause me, by the way, and try it out if you want to try it out from here. So that y is 2x plus 8. Now that I know that is the isolated form, I could rewrite my whole equation so that it's y equals 2x plus 8 and 3x plus 2y, that's equal to 9. Again, in this case, all I'm doing is changing it from that to that by moving things around. I want to make sure that my variable is isolated. Only when it's isolated can I take it and substitute it in for y, because now y is equal to all of that. So now you would have, let's go with block again, 3x plus 2y, and now y is equal to 2x plus 8, and it's equal to 9. All right, now go ahead and pause me and take it from there. All right, so now that you have taken the time to try, we would have solved, and our x is equal to negative 1, y is equal to 6, so our answer is negative 1, 6. And of course, once you would go ahead and check your work to try, then you would realize that, yes, this is my answer. So this is where I found my x. On the right here, this is where I found my y. And then together, they make their solution. All right, this is it. Remember, in order to learn our math, we must do our math. Until later.